Today we're going to take our domain and range a little bit further. You watched the video yesterday that introduced it, or hopefully you watched the video yesterday, but we're going to kind of be bringing things together here. I have h of 4 is what I'm looking for, and I need to find it on this graph. Well, remember when we do these things, this is the h function. They're telling me that this is h of k, and when you plot a point, every point has a value. If I find a kind of nice one right here, looks like a really nice one, that's the point 1 comma negative 3. So I would say h of 1 equals negative 3. And then I go on and find a different spot. Right here looks like a nice one. That's 1, 2, 3, 4, 5. So this is the point 5, negative 2. It's kind of hard to write in that spot, but that means h of 5 equals negative 2. h of 5 equals negative 2. I'm getting too scrunchy there, but hopefully you kind of get what I'm getting at. If I go here, I have another one. That's the point 1, 2. And so h of 1 equals 2. If I want to find h of 4, I'm going to go over to 4 and figure out what that point is. Well, that one is 0, because that's the point 4 comma 0. h of 1, we already answered that one. h of negative 4 means I go over to negative 4 and I find that value. Well, that one's not super easy to find. I might have to approximate that. Maybe I'd call that negative 3.75, because it's definitely more than negative 3, but not quite negative 4, and it's more than halfway, so I'd say negative 3.75. Is this a function? Remember our vertical line test that we do? Is this a function? No. Why not? It fails the vertical line test. Now, looking at a graph is not the only way to evaluate a function. In fact, most of the time we evaluated our functions by using the function itself. If I did a problem like number 2 here, where they give me the function, if I want to find f of negative 3, what that means is I do 6 over negative 3 minus 3, which is 6 over negative 6, which is negative 1. And so f of negative 3 is negative 1. Same thing with 0. This is in the function. I replace x with 0. So this is 6 over negative 3, or negative 2. Therefore, f of 0 is negative 2. So I can evaluate those function values as well as find them on a graph. My next one is 2. So this is 6 over 2 minus 3. 6 over negative 1, or negative 6, so f2 is negative 6. When I plug in 3, something funny happens, though. And so when I plug in 3, you'll see if you do this, you get 3 minus 3, or 6 over 0, which is undefined. If you try to evaluate that in your calculator, you're going to get an error, a domain error, some of the calculators say, or some of them even say it's undefined. Well, that's a value. That means to me that 3 is not a reasonable input. In fact, it's not an input that I can use. 3 does not work because it comes out undefined. Are there any other inputs that will not work in this function? I don't think so. I don't think of any. I can't think of. I'm going back and looking up there and trying to think of any other value that I could pick that's going to make this function not work. And I can't think of anything. The only one that's going to cause trouble is if I put in 3 and it comes out 0 on the bottom. So none. The set of numbers that can be used for x, you hopefully again learned yesterday, is the domain of the function. And so the domain of the function above is every number except, I would say every number except x cannot be 3. That's the only issue. That's my only problem. So my domain is every number. In fact, sometimes we call this all reals, comma, with the stipulation that x cannot be 3. That would be another way to write it. We've seen this symbol before when we were solving equations. So now let's look at our g function. Is g of x a function? Looks like one to me. How do I know? Because it passes the vertical line test. Remember what that was? That means if I draw a line in here and it crosses the function more than once, so I keep drawing vertical lines in here, and if it crosses the function more than once in a spot, then it fails the vertical line test and it's not a function. If I go back up to the top, look at this one line that I draw here, failed because it's crossing that line more than once. This one I don't have that problem, it never crosses. It says which x values have points on the graph. That means, what is the domain? Well, the x values start at -2 and go to +4. And we learned again in the video yesterday that those are including. So we put those square brackets on the end. We could also write this as -2 is less than or equal to x is less than or equal to 4. Either way is a reasonable way to write it. This one is just an easier way to write it. Now let's talk about the range. So we are looking at the possible outputs for the range. And Joe thinks the range is -1, 0, 1, 2, 0, and -1, 0, 1, 2, and 3. Is he correct? So let's take a look at this graph. Although, yes, those are points on the graph, definitely -1 is a point on the graph, and 0 is a point on the graph. 1 is, 2 is, 3 is. But what about all those spaces in between? So we've got to include everything, not just 2, but 2 1/4 and 2 1/2 and 2 1/3. And not just, when we're talking about our range values, not just 3, but everything in between. So when I talk about range, I talk about the lowest value to the highest value. And so my lowest value is here at 4, 0, output of 0. My highest value is here at 0, 3, output of 3. So when I talk about my range would be from 0, including 0, that's why I do the square bracket, to 3, including 3. Those are my output values. Okay, so now we're going to get a little bit more formal in writing our things and kind of talk a little bit more about ways to write it. So how do you write it? How do I write? Let's say my range goes from -4 to 10. We do bracket -4 to 10 and then bracket. What about 5 to infinity? Well, infinity is a little bit weird, and these brackets mean they include that value. But because of it, infinity is the way infinity is, you can't ever get to infinity. It's always just a little bit bigger, a little bit beyond your reach, a little bit further out. So I would go from 5, include 5, but at infinity, I would have to use the soft parenthesis. That's for not including. Again, if you watch the video, they did the soft parenthesis when they had holes in the function, like an open hole at an endpoint. So negative infinity works the same way. This would be negative infinity to 10, and then we put that closed bracket on. All real numbers, that means from negative infinity to positive infinity, I write it just like that, negative infinity to positive infinity. Or I can write it in that big R that we talked about before. How do you know if we're talking about infinity? Well, when you have arrows on the end, that means infinity's involved. If you don't have arrows on the end, that means infinity is not involved. So let's go through domain and range, talk ourselves through it again. Domain. Domain goes from the furthest left point to the furthest right point. It's the width, basically, of that function. And so my furthest left is -3, my furthest right is +3, and those are included because it's solid. My range deals with the height from the lowest point to the highest point, and that looks at the y values. So when I talk about my lowest y, it's -3, and my highest y is +3. Is this a function? Nope. Fails the vertical line test. It crosses more than once when I draw that vertical line in there. Let's take a look at my domain for the next one. So the furthest right, well, this goes forever and ever and ever. To the left, it goes forever and ever and ever. To the right, it also goes forever and ever, ever down, and forever and ever up. So when we're talking about our domain and range, we have all reals, or from -infinity to +infinity, on both of those. Is this one a function? Yep, it passes the vertical line test. Nothing crosses there. How about the next one? Now I don't have arrows on the end. No arrows on the end. I have solid points. So again, I need to look at my furthest left. So I'll line this up. My furthest to the left is here at -2. My furthest to the right is here at 4. So those values go from -2 to 4. And then I'll do my domain. So my lowest point is there at -4. My highest point is there at 2. So when I talk about my range, I go from -4 to 2. Try a couple more. Oops, wait, is that a function? Passes the vertical line test? Yes, it is. All right, domain. So left to right. These are a little tricky sometimes because it looks like it's going to stop, but really this arrow is telling me it's continuing forever and ever, not only down forever and ever, but also to the left forever and ever. So when I'm heading in these directions, this is going to continue forever and ever from left to right. My domain is -infinity to +infinity. How about my range? How about the height? Well, it tops off here at 4, but the bottom goes on and on and on and on forever. And so my lowest point, you always go from the lowest, is -infinity, but my highest point, it tops out here at 4. Is this a function? Yep, passes the vertical line test. I can't draw a line through it twice. Let's take a look at another one. Domain. Remember, domain is left to right. Leftmost is here. Rightmost is here. So my domain goes from 2 to 4. Lowermost, uppermost. So my range goes from -3 to 2. Fails the vertical line test, therefore not a function. And one last problem. The same thing I'm going to be looking at. My leftmost point, go down to the x-axis, and my rightmost point continues forever. So leftmost is 0. Remember, I'm following along the x-axis, 0 to forever, so to infinity. And then my range, the lowest point right there, highest point goes forever, so this is going to rise up forever and ever. So my lowest point is at, it looks like 1, 2, 3, I would guess. So 3 to infinity. Function, passes the vertical line test, therefore yes, a function. Answer the questions below on the Google form, and then you'll get your homework assignment and a little more practice on this tomorrow.